Right, so part B, I've just moved it down so we can anti-diff with more space. So let's get into anti-deriving this. If you want to anti-derive fx, we put it in the integrand. So 3 divided by x minus 2 minus 2x plus 1 x squared plus x plus 1. Of course, we anti-derive in terms of x. Okay, if you look at the first term, this is a log. You have x to the power of 1 on the denominator, then there's a number on top, clearly a case of log. If you look at the second term, this one is a little bit more tricky, but if you look closely, the term on the denominator, if you let u equals to x squared plus x plus 1, you derive it, you get 2x plus 1. What does that look like? The 2x plus 1 looks like the one on the top, so you can actually eliminate things. So what happens here is the first one is a case of logs, and the second one is a case of simple sub. Remember simple sub? Yes, that was the one we learned before. So that's what you want to, that's how you should tackle this question. And if you want to set out your working out nicely, separate them into two separate integrands. So 3 divided by x minus 2 dx minus 2x plus 1 over x squared plus x plus 1 dx. Okay, so separate them into integrands, then anti-diff them separately. So what I prefer with the working out is you anti-diff them at the same time. So what I mean by that is you get rid of the integrand at the same time. Okay, so let's have a look over here. On the second term, I let u equals to x squared plus x plus 1. And if I derive this, the u dx, you should recognize it immediately that, yes, it's 2x plus 1. The 2x plus 1 actually cancels out with this 2x plus 1 here, right? I should use this way right here. Dx is du over 2x plus 1. And then of course, if I was to rewrite this again, 3 over x minus 2 dx minus 2x plus 1 over u, because u is now x squared plus x plus 1. Dx is du over 2x plus 1. What happens to the 2x plus 1? They cancel out. And then you can start anti-deriving. Okay, so 3 over x minus 2, you get 3 log e. Make sure you put the mod x minus 2 and then minus. So this one over here is just 1 over u and then anti-derive in terms of u. You get minus log e mod of u. Okay, now I'm going to replace the u with x squared plus x plus 1 so that we can save some time. And then at the end, you put a plus c. So the reason why I anti-derive them at the same time is you can put the plus c at the back just once, okay? Instead of having plus c1, plus c2, you can just put a plus c. Whereas if you anti-derive one at a time, you have to put plus c1, and then this one, when you derive it, you put the plus c2, and then you can combine them into c, which, you know, is a little bit of, it's a little bit time consuming. But that's it. If you anti-derive this, guys, this is what you get. I think if you read the question again, it says find an antiderivative. So technically, you don't really need the plus c. So up to you, you can put the plus c or you can just not put the plus c, right? So that is part B. I'll do part C on the right hand side. Let's go read the question. What is part C? Hence, evaluate the definite integral of fx with the upper and lower terminal being -1 and -2. So part C. Anti-diff, -1, -2 with fx. So what is fx? Well, I'll just write fx just so that we can save some time right here. -1, -2, we know we anti-derive fx. What we get is this function right here, right? So 3 log e mod of x minus 2 minus log e mod of x squared plus x plus 1 inside the mod, and then we sub in -1 and -2. There's a lot of ways you can go about this. You can combine the logs together. You can, you know, or you can just like sub it in. I'm just gonna sub it in. But yeah, you can definitely go log e x minus 2 to the power of 3 divided by x squared plus x plus 1. So you can combine the logs together. That's also an option. That's also an option. So 3 log e minus 1. I'm going to sub in -1. -1 minus 2 is 3. Minus 3, but mod of minus 3 is 3. And then we have minus log e. Once again, -1 squared is 1. 1 minus 1 is 0. 0 plus 1 is 1. So that's the -1 all done. And then you always make sure you put the minus when you sub in the next one. So let's sub in -2. -2 minus 2 is -4. So we get 3 log e of 4. And then minus log e. I'm going to sub in the -2 over here. -2 squared is 4. 4 minus 2 is 2. 2 plus 1 is 3, right? So that's what we get, and then let's combine them together. 3 log e3, can't do anything about that. Log e1 becomes 0, so it just disappears. And then you have minus 3 log e4, and of course plus log e3, because minus minus log e3 plus log e3. Let's try to combine a couple of them. Okay, so 3 log e3 plus log e3, that is 4 log e3 minus 3 log e4. You can technically leave your answers this, but I believe the textbook answer combine the logs together. So what you can do here, so that to make it similar to textbook, is you can bring the 3 to the power 4 up over here, and then you can bring the 3 up here as well, so that's 4 to the power 3. And of course, log e3 to the power 4 is log e81 minus log e4 to the power 3, that is log e64. And then you can just, if you have two logs, one log minus another one, you can divide the function in the inside. So that's log e81 divided by 64. And if you want to get it as exact same as a textbook, we know that log e, so 81 over 64, another way of writing that is 9 over 8, and then you square it, right? And of course, you can bring the 2 back. So yeah, I mean, this is just essentially just trying to match the answer to the textbook, guys. But that should be the final answer, okay? So that's it for this question. The hard part about this question obviously is the first part, the partial fraction. Once you get the partial fraction, you just have to recognize that yes, you can do simple substitution, you get a log as well, and then yeah, everything else should just flow through. Anyway, thanks for watching, guys. This is question 14, chapter 7F. Hope you found it useful. Leave a like if you did. Aside from that, thanks for watching, and I'll see you in the next video.